This then is a combined air assist and laser module 3D printed part that comes from a design off of Thingiverse. Switch the laser on, you can see the dot down there. There are a couple of things I'm not entirely happy about with this configuration. The air assist hose is a bit of a drag, quite literally. As well as being a drag, the compressor that I have is incredibly noisy and probably overpowered for the task intended. Also, it vibrates so much that I've had to string it from the rafters. Not an ideal solution. And the laser pointer is not very well fixed and tends to wander around, resulting in me having to make sure that it's centered on the laser spot every time I use the machine. Definitely time then for an upgrade. Looking around on the internet, I think I've found something suitable, which I will show to you now. Here then are the contents of the kit that I've purchased. This comes from XS Robotics in Germany. As always, links down in the description to where you can find these products. And I think it's good to be able to source something from within Europe for a change. So many videos I see, parts are only available from the US. I'm sure XS Robotics are able to ship worldwide, so it shouldn't be a problem there. What do we have then? A very nicely 3D printed, better job than I can do, holder. The two line lasers go in there. Obviously this fits over the existing laser nozzle with an opening there for one of these little centrifugal fans, similar to the ones you get on 3D printers and for cooling laptops and things. This is a 24-volt fan, so important to note that. And that will fit into the housing there and obviously blow air out. Now, whether this is going to be strong enough, I know my other compressor was over the top. We'll see how this does in comparison. Also in the package then, two of these line lasers that generate the crosses for you to set up on your laser point. Note that these are 5 volts. Do not get those confused. If you apply 24 volts to those, no doubt they will emit the magic smoke, never to function again. Also in the kit then, a nice drag chain there to keep the wiring nice and tidy and out of the way of things. Another 3D printed plate. And in this packet here, the necessary hardware and 2 switches, one for the line laser obviously and one for the air assist. Now I'm actually going to be connecting my air assist to a relay which is on my Garble controller board, so I'm not going to be using that one, but the switch for the laser crosshairs will be useful and the other nuts and bolts that we shall need. The instructions for assembling are pretty straightforward. If you need extra advice, you can go to this link here /AA and I will show you the PDF file with the instructions on it. Here we see then the PDF document with the descriptions. As I said, everything's pretty straightforward, but good to see that they have some documentation here, and you can always email them for any additional assistance. Mount the drag chain first and insert the lasers. Those are held in place by some screws on the side. I guess you shouldn't over tighten those. Extend the fan wire as required. Drill some holes in the case. If you're going to do that, take extreme caution not to get any swarf or nasties anywhere near the power supply. Mount the drag chain onto the laser head and fit the nozzle. Again, that's held in place by a screw or screws. Wiring, 5 volts there for the lasers and 24 volts for the fan. Do everything at your own risk. Make sure that the laser is unplugged from the mains before you touch any of the wiring. And some advice here on how to set up the crosshairs at the correct point for your particular laser. I have a separate video which I'll link to where I show 2 different ways to fire the laser from light burn. Have fun. Yep, I'm fully intending to do that. I'm going to go ahead now then and assemble and install my air assist unit. Once that's done, then we'll be in a position to test it out. What I decided to do then was, on the mounting plate here, just put a little piece of circuit board that I could solder my wires to, which would make life easier if I needed to change one of the lasers or the fan or whatever. And also to mount the on-off switch for the crosshairs on there. To solder all that together, I've been using this little iron, which is completely cordless. It's what I jokingly call my vape iron. It's essentially the battery and power that would go for a vaping cigarette with a soldering iron bit on it. And I'll leave a link to my other channel where I reviewed this, and people were very dismissive of it and some quite derogatory comments, but I find it very useful. If you're out and about and you've no access to electricity, then this little guy is ideal. There, I think that's quite a neat job. Just before I mount this into the machine, a couple of notes. K40 being a generic term, there are hundreds of factories making them, I expect. The mount that was provided actually fouled on the edge of the lens enclosure. You can see here the little curve that I've made, and that was done just using the sanding drum on your standard Dremel. One other thing that I did, the screws to hold the lens, rather than just forcing them in, I did tap them with an M3 tap. They now run very nicely, and there's no danger of stripping the plastic out or over tightening them onto the lens. I'll go ahead now and do the final assembly. Here we can see the whole setup installed then. I've gone ahead and lined up the lasers. A couple of things to note. Look where the height of the 3D printed part is. It's quite a way up over the bottom part of the lens. As you probably know, the bottom part of the lens unscrews for cleaning. It needs to be pretty much in line or a little bit above that, so that the 3D printed nozzle, which comes down lower obviously than the original, doesn't hit on the strange exhaust vent at the back there. Now that we have this nozzle underneath the laser, you obviously can't measure directly from the laser to the material. What you should have done before is to make up a little guide piece. The distance here is the distance between the top of the gantry and the material that you're going to cut. So as you can hopefully see there, that's leaving the 1/8 gap, which is the size of the material. Let's make this clearer. When I put this down on the top of the gantry, then adjust the height of your bed by whichever method until the indicator stick just touches there, and then you know that you're in the right place. Otherwise, adjusting the lasers, you need to unscrew the lens at the end to get the width of the beam. Let me show you. Hopefully you can see the crosshairs there, and that's focused down onto the material with the width of the line which I prefer. I've also lined them up vertically and horizontally. We're now going to check by doing a test burn that all of that is in the correct place. Things are going to get a little bit noisier now. Just going to turn off my laser. What I'm going to do then is just to burn a simple cross, and then we can check the alignment of our pointers. There then we can see the X that it's burned. I set the origin of the laser beforehand, so now if I go to origin, switch our line lasers on, you should be able to see there that it is pretty much spot on. Let me just adjust the camera angle. Hopefully you'll be able to see this. I think we can see a little bit better there. So my laser pointer is almost exactly over the burned cut mark. The other thing that you couldn't see was that the fan was spinning. Let me turn this thing off, make things a little bit quieter. Yes, as I was saying, you couldn't tell probably because the lid was open, but the fan is spinning, and although it doesn't produce the amount of air that my original did, it certainly seems to function. I've done a couple of test cuts and all looks to be good. I hope you found that useful. As I said, links down below to where you can buy the kit, so I think it's a very good deal at some €35 plus shipping. Many thanks for watching.